can, yeah. Oh no, it's live already. Wow, that's way faster than when we used to do it with Think Distributed. It would take like 40 seconds or something. So it'd be like 40 seconds where me and Bayless would just be sitting there like afraid to say something because you'd be afraid that the recording would kick on like right while you were in the middle of a sentence.
Was that your old laptop before the Air?
No, that was the Air.
Oh wow.
I'm like 2 laptops past that now. I was watching Sean Kerr's Recon talk yesterday where he spilled water on my laptop. Like it's in the talk.
I love that part.
Yeah, I totally forgot about that, right? Like, okay.
Oh man, yeah, I love that part.
Wow, a lot of people dropped off. Are they moving to the YouTube version? Or they just don't like us anymore? I think we're obnoxious.
Afraid of talking, I think.
Yeah, they're afraid of expressing their opinions. This is a safe zone, man. This is a safe zone.
Yeah, it's safe.
Safe room.
Zone, man. Oh, there's Gordon.
Is it safe? I don't know.
No.
Um,
I was getting really choppy sound earlier, so I dropped off.
Okay. All right. So maybe we're good to go. Sure. Okay. Cool. All right. So I guess I guess we're gonna talk about the Impala paper, right? So yeah, I mean, I organized this thing, and Zishan said that I should pick the paper. So I picked the Impala paper, which I read when it first, I think they tweeted a draft like right before CIDR or something. The CIDR papers were announced. So I read it then, and then we decided to do it, and then I ran out of time because it was really busy with Eurosis, and then I got tremendously ill. So I was able to read. I was read everything basically except for the evaluation. But I mean, whatever, it's an evaluation. So,
the evaluation is very skippable, and that's in my opinion.
Yeah, I mean, so maybe somebody else can talk about the evaluation or something. So, I don't know what would be more. I don't know what would be like most beneficial for people to, like how people would prefer to talk about it. So, did everybody in the Hangout at least read the paper?
Yeah, but it's fine.
Aye.
Yep.
Maybe you can try to do a little very quick summary, and then we can sort of ask people to see if we can want to dive deeper into some section or just.
Okay. Yeah. I mean that works for me. Yeah, I can do a quick summary from memory because I didn't really take any summary notes because it's the third time I've read the paper.
How about you just
which I
looking at
should.
the headlines?
I can kind of like talk about the high level stuff. Okay. Yeah, so I guess high level thing is that Impala is basically a SQL. It's like essentially a SQL engine for doing high concurrency, low latency, like kind of business intelligence analytics SQL type queries, right? And so it like tries to basically it's from Cloudera, right? And there's a ton of authors all who work at Cloudera, and it tries to take like a super industrial kind of focused approach from the implementation of the system. So they're trying to obviously optimize on systems like Hive and whatever the other one was that predated that.
HBase.
And what's that?
Was that HBase or
Pig, maybe? Pig was the predecessor to Hive?
Pig, yeah, Pig.
Okay.
Yeah.
So they basically try to do this, so it's SQL on top of Hadoop, right? And they don't like, so I don't know, the high level kind of approach that I took from the paper is it's super practical, super industrial, right? Like they approach it by saying that they want to integrate all of the standard components. They want to be able to run on HDFS or HBase. They want to use normal clients that connect via ODBC or JDBC. They want to have like standard authentication, and they want to basically be able to use any of the file formats that are like widely deployed in like Hadoop style systems, right? So it's taking a super practical and industrial approach to it because obviously this is a product they're building to sell effectively, right?
But they do, right? I mean, they do sell it, right?
I don't know if they sell it or they sell support for it. So I mean, effectively they sell it, right? Yeah. No.
Yeah, I don't know. Yeah. They had a help page. I saw a help page around it, so I wasn't sure.
Does
Okay.
anyone know what Cloudera's relationship is with Pivotal?
As far as I know, there's none, right?
Yeah. I
Um,
don't know if you guys have ever looked at Greenplum or have followed any of Greenplum's sordid history with EMC and Pivotal.
not specifically.
Yeah,
Um,
I mean it's MPP, right? So, but it's all based on Postgres, and they actually allude to that here.
Yeah, they absolutely do allude to MPP. So I'm actually not super familiar with the MPP stuff.
Yeah, neither am
Sounds like
I.
a marketing term to me, because I was like, what the hell is MPP? And I'm reading along, I'm like, oh, massive parallel processing.
Yeah,
So-
it's basically what Greenplum did was they took Postgres and they sharded it.
Okay, all right, that makes sense. Yeah, okay, and
Right.
yeah, so completely disjoint data between nodes, but did they allow you to query join data across?
Yeah. I mean, you have the full power of SQL. You can do joins, and
Okay, interesting.
but
Yeah,
I think
so
but it's not over HDFS, right? And I think that's where you know, again, it's kind of the tail wagging the dog, right? Pivotals, they're getting they're trying to figure themselves out too, right? Because they started out with Postgres, or they started out with Greenplum, and then suddenly it was all, oh no, we didn't mean that. What we really meant was Hadoop, right?
Yeah,
And then-
so I mean that could make sense about this line in the paper that basically says, unlike other systems, forks of Postgres.
yeah, right.
That sounds like it's kind of a like a little kind of fuck you, like kind of nudge like kind of thing that only certain readers would potentially get, right?
Yeah. Anyway, it's not. I'm getting away from the technology side. We should get back to the technology.
Sure. I mean, the history is super important, right? I think a lot of these papers, like a lot of these older papers from the 80s and stuff, the history is really, really important because they're solving like a very specific use case, and we're like, that use case is dumb, and then we're like, well, that was a really valid use case then. So, I mean, the history is important to a degree, but yeah. So I guess I mean I'll just say a couple more words on the paper, and then maybe we'll kind of open it up and kind of just get people's opinion, like their general takeaways or something. But yeah, so I mean I guess I don't know. One thing that I found very interesting. So it's a total ground up solution, and they kind of really talk about that, right? Like the GA is effectively in 2013. They have the most recent release in 2014 that they talk about. This paper is 2015. It was probably in development for at least a year to 2 years, probably before that. So I think, yeah, I don't know. That's a pretty strong takeaway that, you know, as much as they try to talk about like this like big system that seems like super straightforward, it probably took a significant amount of engineering to get working correctly.
It's just that we're an agile, man. You know, otherwise it would be like, you know, Q2, Q3, boom.
Yeah, I mean, they should have just had citations to the Jira thing, but they didn't. So I mean, yeah. But so I
Should have been
guess
Cider 2013.
what?
Should have been Cider 2013.
Yeah. Yeah, I guess so. So my general takeaway of the paper is that it's a super. So I actually really So I think that the contribution of the paper is pretty strong, like in terms of the deliverable. Like they produce an artifact that I think is pretty strong, and they kind of really talk about some. I mean, the evaluation section again. I only read it once, but like when the first time I read the paper, but it seems that it's a very strong result, and it talks about a system that's like actually used in production in the development. But in terms of the paper writing, I found the paper extremely difficult to read because so many of the sections were very ambiguous, and that was one of the down points for me for the paper. So specifically, I'd say the architecture section is poorly organized. I felt that there's an entire page dedicated to the state service. Which I think probably could have been 2 paragraphs. I think it was not explained well. I think that there were, I think that the second and third paragraphs where they talk about how they kind of like keep, so it's weird, right? The paper like leans heavy in certain directions. So they talk about the catalog service, which is interesting for a paragraph, right? But then the state store, they have an entire paragraph that talks about the formatting of the tuples. and how they update things. So I found the paper really inconsistent because you go from like highly technical about something that's actually not interesting at all. I find the state store to be not interesting and kind of a stupid implementation of it, to like the catalog service, which is just kind of like, yeah, we distribute like these topics things on top of this like thing, and we put some metadata in there, and yeah, that's it. So I found that was really difficult to understand because, and I have a couple specific points I'll bring up in a minute, and then when they move to the front end and the back end implementation, again, that same pattern kind of happens where things are glossed over and then some things are talked about in detail. So I found overall the presentation, you have to consider that the first 6 pages or so are on the design of the system, where the final 6 pages are kind of dedicated, or something like that, or dedicated to evaluation and roadmap. So yeah, so I didn't like the way the paper was written at all. That said, I think that the ideas in the paper, or at least like the general system that they're trying to build, is extremely interesting. So that's kind of one of my takeaways from an initial reading. So I don't know if people would like to share what they thought of the paper.
I mean,
That's usually a telltale sign, right? When you only dedicate the paragraph to something, just don't look under the rug here. It's not important, I don't know.
I don't think that's what it was, though. I think like this is a paper, an industry paper, almost written by a bunch of people who are not academics, right? And they're trying to fit this sucker into 10 pages. It's possible they could add a bunch of stuff there, and like the person who worked on State Store was a better writer, maybe wrote some of that, and like this is what we have to squeeze into this paper. That's more what it seemed like to me than.
Yeah, I agree with you. I don't think it was malice. I think it's just poor organization of the paper. They probably had too many people writing, and then maybe they either probably had 1 or 2 scenarios. They were under the page limit and tried adding technical details, and then it ended up not being even because they were like, oh, we have a page, so let's add some technical stuff, and now one section is really technical. Or the opposite happened where they had to cut, and they didn't cut evenly across the paper, so that you ended up with this presentation that's like biased in one direction based on the section.
So I guess like I only read the first 3 sections, so like that's the part I could talk about. I'm looking at the front end part. Like I'm actually not that interested in that at all. Like the most interesting part seems to be the back end and the LLVM code generation. So like I don't know whoever read that. Like can you guys talk about that and what you found interesting about that?
About which sections?
the LLVM code generation.
Section 5 back end.
Generation.
And what you said about that.
Andrew?
Yeah, I thought that was pretty interesting. I'll take a stab at trying to explain it. I don't fully understand it, but they were talking a lot about the cost of virtual functions, vtables, virtual dispatch. I assume this is largely in the context of C++.
Yep.
So they leveraged LLVM for essentially doing some just-in-time compilation, and it sounded like swapping out virtual function calls with stuff that they could inline or that the compiler could inline.
Yeah, so they can actually trace it and make those optimizations.
Yeah, I don't know how they did that. That kind of sounds like a little bit of magic. And
it's basically.
Yeah. Go for it, Andrew.
No, I mean, you can just imagine, instead of generic AST and expression evaluator, they basically just write the code for it. And the other people do that in the commercial databases that are pretty good at that. There was a talk at FB Boston where they basically, it's possible. LLVM makes it possible. It's not too complicated except for the fact that you're compiling code across machines, and that's always tricky. But the interesting bit was that they would never really tell you that there's a threshold beyond which that's too much overhead or too little. So if you're doing analytics, for example, and you're getting a lot of data, you have a good chance of that, the threshold actually being low enough that you don't care. But you could do, if you start doing smaller queries with that, then you get all this, you're actually compiling code to run the code to the query, and that might not only take very little time. Yeah.
It's how much of the code. Some of the code generation seems to be at query runtime, but if it's a schema database, presumably some of the query generation could be done at query definition time. But they were really unclear as to which bits they were compiling, when they were compiling it, and how they were orchestrating the compilation across the cluster. I found that.
Yeah.
just not talked about at all.
Well, I mean, no, they specifically mentioned that it's Hadoop, right? So it's not fixed schema. You can't know. The query allows you to load any data item at any time, and you don't know. You provide a mapping when you run that create table statement, but your query could be done before it has information about that, right? So, I mean, they specifically say that like they have to do like general purpose stuff, right? Because I thought they did somewhere in here.
They do somewhere, yeah.
Oh, yeah, they'll do.
Because they don't know the stuff at query time, right?
But the thing is, whatever the code you generate, even if it handles missing data or not, it can be made more efficient by doing that. But yeah, the distribution is funny because if you have different machines, you cannot really distribute that. Basically, it really is more robust to compile it in every machine, which might not be a bad thing.
Yeah, I mean, I took it as, I guess, yeah, I mean, maybe this is why we were saying that the paper isn't clear about it, was that I took it as I mean, you have a query that's going to be executed on a bunch of machines, and you're going to fragment that right out. So you generate, you have some single execution thing, you generate this multiple execution plan, then you write all these, basically these we generate all this code for these individual executions and send it out. So I was under the impression, and maybe I misread it or it wasn't clear, that you could do arbitrary redistribution given that, given if you knew data placement, right? If you have HDFS nodes that are essentially HBase nodes or something that are essentially replicas of each other, the program theoretically, if it was written in an abstract enough way, or general enough way, could be redistributed to one of those other nodes, right?
Yeah, but the output of this is machine code, so they would have to be exactly the same kind of machine.
Yeah, well, I mean,
mostly, yeah. So that's the tricky. Like well, anyway, we can guess what they did. It's probably not that important. The concept itself of optimizing the code, I think it's the important thing. I know who cares about the details really.
Yeah.
After that.
Chose to do this instead of just using like a JIT, like an off-the-shelf like JIT tracing VM. Like they say that their C++ is faster than Java, but like Java does this.
Well, Java does it if you let it run for enough time, right? Like the hotspot will kick in at some point.
If you warm it up.
And probably if you run the same code all the time, right? If you start to load other classes and.
Yeah, for queries it's kind of different, but it's why not try C++ if you can. But really, yeah, JIT will probably do a good enough job for like if you actually knew your queries and you were repeating them. But anyway.
So explain this though. I mean, this is what I'm trying to understand. If it is JIT, then the LLVM runtime is loaded into memory on the node, right? And it's optimizing code execution paths while the query is being run.
Well, you have a query that makes, like, say, a big computation out of some table, gets a bunch of values from a row, adds them together, creates maps, blah, blah, blah. That's the code that you would LLVM.
Yeah, but I mean, hold on. Going back to the thing, like going back to Andrew's point, you bring up the JIT, right? I mean, they have a section here where they specifically say, like, where they compare it to the JIT, right? They don't say what the downsides are. So I think this is another artifact of it being written poorly, is that they say JIT compilation has an effect similar to custom coding a query. For example, it eliminates branches, unrolls loops, blah, blah, blah. And then they say code generation has a drastic impact on performance, shown in Figure 4. And it's kind of like, okay, so you just mentioned the JIT, and then you talk about your code generation, like one sentence apart, right? And then you reference a figure. But you actually don't talk about like why it's different, right? Like, so that's kind of weird. It's like they make this claim that like the effects are similar, which is unsubstantiated, right? They don't call out the specific differences. I mean, you can't just say JIT because there's like a million JITs, right? And there's a million ways JITs work, and like JITting is a huge field of computer science, right? Like, so I mean, like I feel like that section is like kind of vacuous because they're not like kind of saying they're not stating like the problem. So a better way that it should have been approached is that they should have stated that we could do X with the JIT, but we're trying to achieve Y. The JIT is insufficient to achieve Y, so we apply code generation, which is sufficient to achieve Y. So I feel like
you're too nice, man.
The JIT might be a valid solution. They say it's not, but they don't say why. So okay, sure, whatever, right?
if you say like, oh well, you know, this does it, but we do it better, and here's a graph, you're just trying to sell something. Like,
Yeah,
you're being too nice to
the
them.
worst conference talks, and the worst conference papers are ones that say technologies A, B, C, and D are all terrible, but E, the thing I just made, is awesome. But they never state the initial problem. Like you
But
can
it's a
criticize
beautiful
it out
circular.
of everything, but if you don't actually say like what the end goal is, like you're effectively. I mean, it's a logical fallacy, right? Like, but anyway, whatever. And not to
So my
not to take
my
it so
read,
far, but
my read of that section of the paper, they are using the terms JIT and code generation interchangeably, and saying that they either have a code path that does interpretation, or they have a code path that does code gen, aka JIT, in their minds. So, I mean, if you read through that, what they seem to be talking about is either they do everything with it with interpretation, right, and functions and virtual function pointers and stuff like that,
right.
or
do.
they take that same abstract syntax tree and they compile it to native code,
Right.
which is what they're calling JIT, which is kind of a abuse of the term JIT. But
Well,
I guess
no, I mean they define. Yeah. So the problem here is that in section. Yeah. So I'll make one final point here. The problem is at the beginning of section 5.1, they define what they want JIT to be, and they define it as just-in-time compilation. And then they say code gen, right? So their JIT is specifically referring to like some sort of JITting that they have that they don't talk about in depth, right? And then in Figure 4, they show the difference between code gen. So I don't understand if Figure 4 is showing me code gen off versus the JIT or code gen off versus everything. Like I don't know what that graph is effectively trying to say.
It's three.
on and off.
Yeah, on and off with 3 different use cases, right?
I know, but they specifically say that JIT is different than CodeGen, right? They say like CodeGen we can do the best optimizations. JITting we can do some subset, right? And then or you do nothing, right? So is the CodeGen off with the JITting on or with nothing?
See, and I think what they're saying is JIT and CodeGen are exactly the same thing. They're using those two terms
I
interchangeably.
agree with that. That's the impression I get.
Yeah. And in Figure 3, right, they have the example
Interesting.
of the interpreted math expression, right? Or the expression on the left is evaluated through virtual functions.
Okay,
Yeah, so-
I guess if I read it that way that you're saying, I guess I could see that. Yeah, I was thinking that the terms were separate things, but it looks like you're probably right there.
What I don't get is the runtime nature of this. I mean, is this something that they do? Do they take a query and they generate all this code and then execute it, or?
Yeah,
They
that's
Yes.
They
Is it
pass a
being-
query to an AST, and then at certain points that AST has been used to generate native C++ that they execute.
that they compile on the fly?
Yeah.
Yeah.
Yep.
And I think they probably ship they ship quite late in the compiler chain within the query. So they ship out a query with a slump of LLVM, and then they compile it on the target machine and run it.
Yeah.
That's certainly the impression I'm getting.
Yeah, that's
The funny thing is that they don't compare, for example, with other engines that actually do the same thing in Java. Like if you can do code generation in Java and let the JIT actually, Hotspot actually generate the code for you, and I bet it's not going to be that much worse. And I don't see any reference to that. You sort of really.
Yeah. Well, and it may be more a matter of where in the process they've decided to switch between Java and C++ in general, and the fact that this stuff happens to live in the C++ app. I'm trying to remember. They did talk about why they chose C++ for some things.
But it also seems they're also inlining very simplistic things. Like it doesn't seem like they're doing a high-level trace to figure out all the free variables or what they can. It seems they even use the word simple, I think, when they talk about it.
Yeah. It's what we used to do, when we had to unroll inner loops in Fortran, where you assembly code. You've got 8 nested for loops, you've got to assembly code the inner line because you go through it a million times. So is that really row-based access, destructuring rows in binary format coming off the disk, fast, and then doing ops on it, and doing that for every row for 1 million rows. So it is really in a loop, I think, would seem to me, in a loop operations, where you go down the tree to the bottom on the thing you do a lot, and then you try and chip that.
Yeah. Should we? Is there any other section that we want to? Because I actually, all this stuff is pretty cool and stuff, but I'm really more interested in the resource management, which is like if you read some of these papers, the Vertica, they always sort of basically state this as the problem that they have.
Yeah.
I mean, all the other stuff is kind of trivial. Yeah, could do code generation. We can make that quite fast. That's just in matter of coding. But the resource management.
I mean, I mean, that's an interesting observation. By the structure of the paper, that's not what they think's important. But
well, it also is problematic.
They spend like half a page on it, right? And the rest of the paper is on the front end and the metadata management.
Well,
because they didn't do
the resource stuff is problematic, so they haven't really solved too much. The Llama work helps, but it doesn't really go that far.
Llama to boot the boot.
That's right. But I mean, like I don't know, like it seems like the work is not trying to solve the resource problem. My read of it was that they're trying to effectively leverage what's already out there for resource managers, and by using all these industry like Hadoopy things, you know, like Mesos and Yarn and all of this shit.
Parquet.
Yeah, but by using these, by basically building into that ecosystem, my opinion is that, well, you let Mesos solve the resource problem, right? Like we just find a way to effectively distribute something over dynamic membership of whatever HDFS or something, like, and then as machines become available, Mesos or Yarn takes care of it for you, right? I mean,
well, they had
and then when it doesn't work, you just slap another layer on top, and then keep moving.
I mean, this seems like a freaking nightmare system to work on, to be honest.
Yeah,
Yarn wasn't quite good enough for what we need because we can dynamically change our resource requirements while we're running a query. So let's stick something in front of it and then just ask for more stuff from Yarn and put it back together or something.
Yeah.
So what is that?
Llama looked like it was just an aggregator on top of Yarn to prevent them from having to deal directly with Yarn.
Yeah, I mean, it's supposed to, well, part of it too, well, no, I mean, it's two things, right? Like, the first thing of Llama is that it provides a way to bypass Yarn when there's no potential.
Right. Fast path,
you can fast path things, right? And then the second one is like some sort of allocation model that they're trying to build on top of Yarn. Like basically trying to like subvert Yarn effectively. I mean, effectively,
well, I mean, it's a good idea.
We got to build some shit around it to make it work the way we need it to, right?
Yep.
It's sort of similar to that escrow protocol in a way. You know, you cannot possibly coordinate all this stuff with one single point. So you know, you just overbook your freaking plane like they do. It's just just like planes.
Overbook and back pressure.
Overbook and back pressure. Yeah. So anyway.
Yeah.
Was what they built in front of Yarn much more than a cache?
Much more than a cache.
Yeah, because they did say it does cache. That was one of the.
I think I read it as they basically get resources in bulk. You know, it's just like they're the middleman.
Yeah. But
so
what does that do for correctness, though? I mean, is it how?
Correctness. Remember, this is resource allocation, so it's not
not caching values; it's caching resources.
No, I know. But I mean, someone needs I need some CPU, right? It takes too long for me to go to Yarn and ask, so I'm going to go to Llama, which might have a cached version of that.
Actually, not cached so much as in there's some guessing that you're going to use this much CPU in a big period, not just like the next minute, for example. Like say it's too costly to get it for the next minute, you probably do it like for the hour. No, I'm exaggerating, but that's the whole idea. You sort of overbook it. Yeah.
Yeah, I took it as like saying that, well, if this cache of resources is stale, then you're potentially gonna over provision the resources on some machine, and things might slow down because you're increasing contention.
Yeah.
I didn't take it as. I don't think that affects correctness. I think that affects performance. Like it's a factor of your cache divergence, right?
Yeah. Wrong term then. I meant correctness of the resource allocation decision.
Yeah. Okay. Sure. It depends on how you define correctness or resource.
I didn't mean correctness of the results.
Yeah. Of course. Yeah. Correct.
And
Here's another problem. Too many goddamn overloaded words.
language is hard.
It does seem that they're actually using Llama to, instead of allocating resource on a per node basis, they're getting Llama to do block allocations across the cluster. That's what it seems to say to me at the end. So that you say, give me a cluster-wide set of memory, and then Impala will then go off and it's not Impala. Llama will go off and make that happen in Yarn on a per machine basis. And then just to make it work better, they put a mission control, which seems to me to be back pressure. The signal it doesn't work so well, so we'll put back pressure on top just to kind of balance it out. It's not the end of the world.
Yeah, the other thing I wonder about in this section is if when they say Llama's resource cache, I read that almost as more like Llama leases stuff from Yarn, and it may have something sitting around that is done being used by the thing that was originally going to use it because its estimate of work was bigger than it really was, but it hasn't returned it yet. So, hey, I can give this to somebody else to use.
Yeah, that actually might be the correct way to read that for sure, yeah. It doesn't really talk about how the cache is populated, right?
Yeah, as I said, I kind of read it as leases, just thinking about resource allocation, but it would be nice if it was clear about what the hell was going on there, or use the term, if we already had a lease in our local cache, we could reassign it to somebody else. I don't know if that's really what they're doing, but that's that's how I read it.
Yeah, it's really terrible that they don't define they mention the word cache twice, I guess. They don't really define how that cache is populated, how that cache is maintained.
And how does this get around the single choke point of, right? Because they complain about Yarn because it's a single resource that you overload. So is this distributed? Is Llama distributed, or is it?
I think Llama sits on every node and then borrows, then holds on to resources instead of sending it back to the center.
Okay.
Because if things aren't too busy, then I'll hang on to it and underutilize, and I'll only actually move towards releasing it when the thing gets really busy. Because when the machine, it seems to me when it's not very congested, there's a lot of cost in going to Yarn for every time you need stuff. So you just hang on to it.
Yeah. Yeah, because Yarn is not meant for, I don't know, at least my opinion is Yarn is not meant for resource allocation for, real time, right? Like, they're assuming Yarn is usually like a MapReduce, like it runs MapReduce, right? So you assume that I'm going to allocate some to shit and I'm going to run this job. Where it seems like here the resource churn is higher because it's a real time system. Or as opposed to an online system, rather, right? Instead of a batch. You're taking queries and you're executing them as they come from the user. So it's too expensive to basically allocate and deallocate resources all the time, so you want to effectively hold onto them as best as you can without increasing too much contention across the cluster.
Yeah, that makes sense.
It's the plight of every single engine on top of Hadoop. Like this batch system used for everything.
Right.
Anyway, yeah.
That was actually one thing I was kind of interested in talking about generally about the use case for this, because, and what struck me was, because this is built on HDFS, they confess that there's a bunch of SQL that they don't support, like inserts.
Okay.
They really only support bulk insert and bulk delete. And then
Which is effectively just loading a new data file or deleting a data file. Yeah.
Right. So it's the use case for, I guess, this system seems to be, I don't know, what do they call data warehouse?
Analytics.
Analytics.
Business intelligence, right? It's the idea that
It's an offline system.
Yeah, but it's limited though, right? This is BI over a shit ton of data that you just cram into the database and then you do your analytics, right? It's not.
That's the Hadoop model, right? That's what MapReduce solves. This is what what Hive is supposed to do as well. Like the idea is that you have a large amount of analytics data that's coming in, or metrics data or something that's immutable, gets written to HDFS, and you want to query it. So I considered it to be the next evolution of those systems, because those systems were kind of shitty.
It's also what makes the problem easy, though, right? I mean, they're not dealing with updates at runtime incorrectness issues.
Exactly. Yeah. So again, like if you look at Spark Streaming and you compare it to systems like that, they assume that batches are largely immutable. Like data files are going to be immutable; they're not going to change. So it's a fundamental.
They do have the ability to talk to HBase, which is sort of like what they sell you in terms of the compromise there.
Yeah, but they specifically mention that HBase is a lot harder problem, right? In one of the paragraphs.
Yeah.
So I'm skeptical how much of that actually is actually correct. And 100%.
It's just like the data platform stuff, right? Like it's a checkbox. You connect. Well, if you have this problem, then you connect to HBase. So you have to be able to connect, whether the impedance is high or not.
Yeah, fair. Yeah. I mean, I had some general comments on the state store that I'll just rant about for a minute, because I complained to Henry Robinson on Twitter about
them. State store has a lot of issues. Am I right?
So the first one is that so the first thing that I said to Henry was that it would be trivial to re-implement the state store as a gossip over CRDTs.
Yeah.
That would make a lot of things better. You could have concurrent updates happening. You could have any node add to it. It wouldn't have to be a single point of failure in the system. You can effectively model exactly what they're trying to do with that solution, and I think that solution is more available than the solution they propose here. But my bigger thing that I drew a bunch of crazy notes about and all this stuff in my notebook was that one thing, and maybe I'm completely wrong with this, but Henry was like, I'll get back to you, is that this idea that you have tuples of information and then a later timestamp kind of eliminates something, right? So the timestamps are okay to be used because you have a single sequencer. So a single sequencer, effectively the node that takes the state store change. So any node can locally make a change, but it has to go through some sequencer to get redistributed back out to all of the local copies. Stores these topics with these key value tuples with a timestamp. Mm-hmm. But what they don't talk about, or maybe I missed it, was that they specifically call out that it's weakly synchronized, but they don't ever say anything about a safety guarantee on the values. So the way I read this, and the way that I drew it out like mathy in my notebook, made it clear that there was an implicit safety property that any changes to the state store about the catalog needed to be backwards compatible, because they make no guarantee on visibility of a given item. So you may go to execute a query and have outdated metadata, and you have no guarantee on the liveness. I mean, you have no liveness guarantee on when you'll see the next update. So I felt there's an implicit safety guarantee, but maybe I completely misread this section.
I mean, it seems to me like they also, I'm not sure. What I got out of it was it seemed like they kept everything in memory, like they never removed shit except for that one where they had to expire. Right.
But they replace so the timestamp, as far as I can tell, is used to replace a value. So you say there's a fact that's known at a given time. So I imagined it like a Datomic-y thing, right? There's a fact known at a given, or like a data log thing. There's something known at a given time. A key has a given value in a topic for a given time. Yep. And then, so it's effectively a list of facts that are accumulated. So regardless if you model it as a list of updates that come in over time that you never prune, or you imagine that you just take the latest one with the timestamp, it doesn't matter which model you actually think about it. There's still a property that's in the system that says that since updates are never coordinated to the local nodes who reference that state for optimizations, they kind of say, well, it's fine. We use this to optimize the execution of things. Well, that's great, but the problem is that those optimizations need to be backwards compatible, right? Because you'll never guarantee. You might give somebody some information and then something could drastically change, and you don't know when they're going to receive that latest update unless you manually trigger this state store update thing. So I don't know. It's very wishy-washy. I'm not convinced that the state store is safe. at all. But
It's clearly going to overwrite. Like, there's clearly going to be lost updates, right? Like, the clients aren't going to get all the updates if they're updated in the state store before it pushes them out. Like,
they do guarantee that eventually you'll observe all of them, right? Because they say that you'll get state from another node. I thought they said something about this.
Yeah, you will get state from their node, but that's susceptible to, like, they don't talk about how they might deal with flooding, like who gets, when it comes back, when the process starts again, the state store, like where does it get, which node does it?
Okay, yeah, that's fine. I assumed kind of a virtual synchrony like type membership model where like
there's no discussion of that, right?
State and you update, right? I guess my concern is that like it's really hard to disseminate metadata state and like operate on it when you actually don't have any epochs to know that you've quiesced. Right? Go ahead.
Remember that this is, when you're dealing with a Hadoop kind of system with a lot of data, data doesn't change that easily. Like, to actually change something that will.
This is not the data, though. This is not the data. This is metadata.
Right, about the data. So
definitely change easily. They're using it to
store.
store.
What I mean is, like, if you're going to reformat all your data, for example, like say that's something that will be reflected here, it would probably be like a 3-day job. At least.
I agree with you on that. However, I think
they're probably hand wavy because
of the catalog that's built on top of the state store and not the state store. So I'm saying in practice, the catalog has very little churn because it's about data, and you only can do it as fast as data changes, right? But the state store itself, outside of the catalog, like the underlying substrate it's built on,
I know.
is, in my opinion, not safe. So sure, they only use it for slow changing things. That's fine. Well, they're probably safe. But like, I guess
that's the point.
They spent an entire page talking about it, man.
Yeah,
telling us what the tuples look like.
The point I'm trying to make is that they know their audience. It's like if you can have a super safe system on top of something that basically that will never really, or like most commonly, will not be needed because changes are heavy and slow and very complicated.
Sure, man. I think that's an excellent point. You know what they should have done? They should have wrote that in the fucking paper, man. That would have been a really awesome footnote to have, that's for sure. Yeah, it might take a while for updates to appear, but that's okay, because we only make like 2 a day.
So that's a big issue with this paper, right? It's like, why the fuck, like what are the big benefits? Like, the JIT stuff has some of it, and they explain it, although clearly if they use templates instead of virtual functions, they wouldn't have this problem with inlining and needing a JIT for C++. But
you cannot do that with the runtime query, man. That's the whole point. Like, they're actually transforming that into what templates would be.
Yeah, that's it. They can't use templates because it's runtime, right? That's the whole reason for the novel work.
I don't understand why. They could generate a specific function for each thing, right? Like, and have it inlined.
That's basically what they're doing. Like, imagine they take your query and they create the templates that you would create and they compile that code. It really is what they're doing, but at runtime.
But in order to inline it, rather than making function calls in vtables, you have to do some sort of compilation step, right?
Mm-hmm.
At runtime, if you have a varying types of data that you're trying to access, you have to do some step like use LLVM to compile things. Otherwise, you end up with vtables or at minimum function calls, and you can't make it as simple as +10, which is what they talk about being able to do, right? If you have a constant value. Stuff like that.
Cool. Okay. So I mean, so we have 2 things that we should talk about. So we should talk about like just some final get everybody's kind of final opinion of the paper. I think will be useful, so we can kind of run down the little hangout list. And then finally, I guess we should figure out kind of
next paper.
The next paper that we want to talk about. So I'll start, and then we'll kind of go down the list. We'll go with Zishan next. I'll go in reverse order on the little bar. But so I'll basically say, so I really enjoyed reading the paper because I like reading about real systems that are new, that try to solve distribution challenges for distributing queries across a cluster, because I think that's a very interesting problem that we still haven't figured out how to do well yet. So this is very close to my wheelhouse, obviously, because this is all the stuff that I'm focusing my personal work on. I found the paper to be it's interesting it got into CIDR because I feel the paper was written poorly. I feel it was organized poorly and focused on. Excuse me.
Is CIDR more of an academic conference? I imagine it is. Right?
Yeah, I guess so. I mean, I think it's like on par with VLDB, but I could be wrong. I know very little about like the database kind of systems paper things. It's not like an ACM thing. It's got like a private endowment or something, kind of like VLDB, I think. At least I think. So yeah, I guess I felt the paper was written kind of poorly. Yeah, so it was organized poorly. It kind of, I think the biggest criticism of the paper, the thing that I would have wrote if I was a reviewer on this paper, would be that the introduction doesn't clearly outline the problems and the contributions. So I would have liked to see a list of saying, these are the contributions, a state store, a catalog manager, a whatever, program rewriting runtime, whatever. So I feel they could have better called out what was novel about the paper, because right now it just kind of reads as like an implementation guide for the system, effectively, with very little technical detail. A 10-page implementation guide. So yeah, so that's kind of my general idea. So Zishan.
Yeah. I mean, I think very similar. I like reading about these systems too. I mean, I was a big fan of like the Dryad Link paper that goes through the process of what it is to do distributed query. And for me, very similar things. I mean, some of the code generation stuff is interesting. The lack of discussion and the issues they've had with resource management is interesting because it makes me want to read more on that side as well. The code generation stuff is also interesting, so I'm reading this paper right now, which is a more high-level functional thing. If anyone can see that, I don't know. Which is pretty crazy, and it gets way more in depth into like probing and like dealing with how to inline code and what, when, and where for higher-level stuff and functional programming through an SML. So some of that stuff is really interesting to me, but I agree with the same issues that the paper seems to gloss over. Things that it really should talk more about, like the cache and that kind of stuff. Those kind of issues I've been noticing a lot more. Is like a dime a dozen. A lot of papers deal with that, have that problem. But otherwise, I mean, I also agree. I like reading about these distributed services for query, and there needs to be more papers that they can go more in depth, but go through all the steps and process that happens for it.
I mean, it all reads to me like a really, really poor man's implementation of Vertica that has no guarantees and nothing. Yeah. But it works. It works with the shit you already have in your data center.
I didn't read this whole paper. I read some more of it while we've been talking. But I mean, this paper compared to the Vertica paper, like I love the Vertica paper. Like that introduced me to so many things and talked about trade-offs and like why they did things. And it was a little bit of a longer paper, so that kind of makes sense.
Yeah, I mean, like, Vertica is a much older system now, right? So.
Yeah, this is how we integrated all these different Apache, Hadoop projects to build this system, and like, it's cool because it is faster and it works. But I didn't find it as novel or as like, I don't know. I didn't get as much out of it.
Yeah, I mean, like, I don't know, I think, like, the comparisons to Vertica get to be a bit unfair, honestly, because I'm not, like, trying to be super negative, but, like, I mean, like, yeah, Vertica was real shit at one point when it was at Brown University and Stan wrote the first paper, right? Like, all of these systems back then, those early Stonebreaker joints that came out of Brown and MIT were shit systems, like, when they first started, and they innovated on them, and they have a massive advantage on some of these newer things. It's like saying, like, no Clojure paper will ever be interesting because Haskell's already done it all, and Standard ML already did everything.
That's not what I'm saying. I'm saying that, like, the way...
No, I know you're not saying that. I'm just saying that, like...
Stonebreaker joint to a Cornknacker joint, man. Cornknacker joints.
Yeah, I mean, like, sure. Simon Peyton Jones did all... John Hughes did, like, whatever. He did all this stuff, like, 20 years ago. Dude should just, like, give up because they'll never see anything cool ever again. I'm just giving you a hard time, man. Come on.
I think that the JIT stuff, that's pretty novel, and like there's things that they did differently. I guess I'd like to see more comparisons with existing systems, and less like we used fucking Yarn. Like yeah, I don't know.
That's a really great. It's a really great point. They should have related work, like a big related work section.
Why the fuck would you spend 3 years building this? Like
their benchmarks go against what they call DBMSE because they couldn't name the system that they benchmarked against. So that's a
proprietary.
Okay, 10 minutes before the mumble.
So I guess maybe we should talk about what if somebody else would like to talk about a paper tomorrow. I mean next Friday, and what it is.
Like,
You can email it out to everybody.
There's a couple of things I was finished talking about this paper yet. Gives a chance.
Oh yeah.
It's quite interesting looking at how the front end bit, how they're building the query planner and how that's fitting together. But a lot of those choices that I'd like to see more detail would be, they gloss over histograms, how they decide which approach they're going to want to do, what underlying stuff they're using to try and calculate their resource allocation. Because it's all very well saying we don't have resource allocation at the back end, but how they're estimating resource required at the front end, no fucking idea. That's sort of which I'd quite like to see a bit more on. And I thought the runtime code generation was quite interesting as well. And it's the benefits that you get of being able. I mean, one of the things we're thinking about when we do the DDL, how do we distribute the runtime code that we are generating that can destructure data? And at the moment that's all straight Erlang, but potentially that whole distribution and how you make sure everyone has a common runtime view of the description of your destructuring code. It'd be quite interesting to see how some of that, but we're not in the same world as them. So, but the other thing that really gave me the fucking dry boats is this resource allocation. How the fuck are we going to do resource allocation? I've got no idea.
Your Coiler for the morning paper, you get to look at the Quasar paper.
I got it open here. That looks like a good one.
I'll put the link in.
But like many of these systems, basically they tell you, it's like, oh man, there's so many resources and papers and all this stuff, and resource allocation, like nobody's doing anything interesting, man. Like we just don't know. We're messing up. I don't know. Just improvising.
Sounds like a good PhD topic, Angel.
Yeah, man, go for it.
But surely, you need to get a working system to start working on resource allocation, don't you?
That's the problem, right?
You know what I mean? Otherwise you're just guessing, right?
Yeah.
This is our resources, we need this, yeah, do you?
So, like, yeah, everybody in the industry.
Some of the Mesos stuff seems familiar, like Brendan.
And Mesos was a PhD project too, so
Yeah, his PhD thesis, like the one that kind of invented Mesos. That's some interesting stuff to look at.
All right, dudes, I have to go because I need to actually eat something before the meeting.
Okay.
Later.
Cool. Anybody else want to share their opinion?
Yeah, I mean, I would not much beyond what's already said, other than you could take any one section of this paper and probably expand it into something. Whether it's query planning, I felt the same way, Gordon. That was like, how the hell does that work? But yeah, and I'd also echo. I like the idea of seeing systems working. I also like the idea of keeping things relevant to what we're working on, assuming we're working on stuff.
Oh, I found that was quite interesting because there's stuff that's similar to things that we're doing at the moment to try and get this time series stuff out. So.
Yeah, I mean, I don't know. I'm generally of the opinion that there's always something valuable, usually in a paper in the database-related field. There's always usually something that I don't know, I think it's important to get out of your comfort zone and try, you're trying to build like a query engine for a distributed system. There's not going to be the golden nugget paper that you find to keep.
No, I agree.
It's really good to just kind of do a general survey of the area and kind of get a feel for what's out there.
No, I found it quite useful.
Okay, so
yeah, next week.
Yeah, next week. Yeah, let's figure out next week.
Shit, man, I had so many papers I want to read, but now I have.
Should we try to spin more towards resource management? Maybe either pick Quasar or Mesos.
Mesos paper would be cool.
Yeah, I mean Mesos is pretty relevant, right?
That one that I linked, is that the right one?
I'd have to look. But yeah, I mean, for all we know, we'll probably have to integrate with Mesos at some point.
You bring up my list of.
Yeah, you want to try to do the Mesos paper and get an idea of just how that system works?
Do it, Stoner.
Yeah, we could do that. I mean, I guess I'm just looking ahead. I mean, shit, now I'm going through, old papers I have, Ocean Store. Just ridiculous. Windows as our storage. We've talked about that here and there at this company.
Or maybe what we could do is people could. I mean, I would be super down for the Mesos paper, but I mean, if people aren't, then maybe they can propose an alternative, and then we can vote or something.
I think the Mesos paper is good, actually, because I didn't read that, and it's interesting, it's relevant, and it kind of builds off where we've gone. And then I think maybe we can, after we get through with like these research database topics, like maybe we switch after like the third week or something to like some separate topic, like
So I'm super excited about presenting. So I would want to at some point. So if I'm going to throw a paper out there that's not super related, but it's related to some stuff that I'm working on right now, I would throw out the paper on order preserving homomorphic encryption. So that is one that I would really like to talk about.
That's an interesting one. All right.
Yeah, so I'll throw that out there, and eventually, at some point, we'll pick it up. But I would just want to put my name in the hat for that topic, because that's a topic that I think is absolutely fantastic, and it's super outside of my realm of expertise. I find it challenging to think about, and I think there's some really cool practical applications.
So looks like I found another paper related to resource management too. Omega, flexible scalable schedulers for large compute clusters. Do you see in HipChat? You're not wrong about integrate soon. Of course we're not, man, because like Mesos is the thing. You got to play the Mesos game, man, if you want to buy into that.
They're doing big money. My buddy Tyler's going there. It's crazy. He was telling me it's crazy.
Yeah, no, it is. Yeah, I mean, yeah, for sure.
Did you guys? What did you think anything about that Lifshitz paper on data log programs, or is that something we don't want to go near?
Do it eventually, yeah.
Yeah, I mean, I think it's fine. We should probably just start an email thread maybe with, so maybe we'll propose Mesos as the big thing for next week, and then we'll kind of get a list going of what we want to do the following week.
Okay, yeah, that sounds good.
We need a Jira board. We can put all the things in there and then drag them up and down, and never mind, sorry.
Somebody go make a Jira card for this hangout, please.
Well, we need our own board.
I mean, I need to account for the hour I spent on this hangout, right? So.
You're not recording in Harvest.
Okay, all right. So any final comments before we finish up? We have 2 minutes.
Yeah, I got to go to the toilet, so see you later.
Bye.
See you. Thanks, guys.